Alright, subtopic 1.3, which is on electric potential. In this subtopic, you have to be able to define what is electric potential, define and explain equipotential lines and surfaces of an isolated charge in a uniform electric field. Okay? And then you should also be able to use this equation for a point charge and a system of charges, maximum 4 charge, and then calculate the potential difference between 2 points, deduce the change in potential energy delta U between 2 points, and then calculate the potential energy of a system of point charge up to maximum 3 charges. Okay, so electric potential. So electric potential is defined as the work done in bringing a test charge from infinity to a point in the electric field per unit test charge. Okay, so the theoretical zero of a charge is at infinity. Okay, so electric potential is zero if it is at infinity lah. Okay, the theoretical zero of electric potential of a charge is at infinity. Okay, so the equation is given here, and the value of Q here, it can either be the value of the test charge includes the sign. Okay, so if it is positive, include it. If it's negative, include it. Okay, and then it is a scalar quantity with the unit of volt ataupun apa suara J tu? I can't remember J. Joule, joule per coulomb. Okay, and then this is a diagram showing that the electric potential will be increasing as you are moving towards a positive charge. Okay, however, it is as you are moving out of the positive charge, the electric potential will be decreasing lah. Okay, now, and then for a negative charge pula dia terbalik lah. Okay, if you are moving inward, the electric potential decreases, and then if you are moving outward, it is increasing. Okay, so what is this equipotential lines and surface? It actually means it will have the same electric potential if it is on the same lines ataupun surfaces. Okay, it is defined as the locus of points that have the same electric potential lah. Okay, so the electric field at every point is perpendicular to the surfaces, and then the electric field will always point in the direction of a decreasing electric potential. Okay, so it will point in the direction of decreasing electric potential. Okay, this is the relationship between electric field dengan electric potential lah. And then the surface is closer together where the electric field is stronger, and farther apart when the field is weaker. And then there is no two equipotential surfaces can intersect each other. Okay, so that's why we draw it. There's spaces between them lah, they cannot intersect each other. Okay, so what it's actually saying is, for these same lines, it will have the same electric potential. Okay, sama juga di sini, it will have the same electric potential. Okay, contohnya di sini pun sama juga. If it lies on this line here, no matter where it is, as long as it stays on this line, it will have the same electric potential. Okay, sama juga lah macam ni. Right, and then so because of that equipotential lines and surfaces, no work is done when a charge moves from one point on an equipotential surface to another point. Okay, macam ni tadi ni. This one is more clear. Okay, why is there no work done is because the potential difference is zero lah. Okay, so if you look at what I'm saying just now, this diagram describes it clearly. So if you are looking at these equipotential lines, if you are looking for the work done for a charge moving from point A to point B, it will be equal to 0. Why? Because the electric potential difference is equal to 0. Okay, because the potential difference is equal to 0. However, if you are looking at point B to C here, the work done is not equal to 0. Okay, it should lie on the same line saja baru dia betul. Macam ni juga, this one lies on the same line, so the potential difference is 0, hence the work done is 0 lah. Okay, and then this is for the electric potential from a positive and negative point charge. Basically, you just have to include the sign lah. Okay, contohnya this one negative kan. Alright, I think that is, oh no, we haven't end yet. Yes, okay. Oh, so this subtopic is quite long. Okay, so potential difference is delta V. It is defined as the work done in bringing a positive test charge from a point to another point lah. Okay, so the electric field is a conservative field, meaning the work done to bring a charge is independent of the path lah. Okay, so if the value of the work done is positive, the work is done on the system, so it needs an external force lah. If the work done is negative, the work is done by the system, no external force is needed. Okay, so let's consider positive test charge moved by the external force F from point A to point B. So from point A, this force is pulling this charge to point B here. Okay, so the potential difference between point A and point B is given by this equation here. This is basically delta V work over the test charge. Okay, that is the formula. So potential difference is the final position minus dengan the initial punya positions lah for the electric potential. Okay, so let's see the situations. Okay, for this diagram, moving the positive test charge from this location to location B will require work and increase the potential energy of the charge. Okay, so it will require work and increase the potential energy of the charge. Okay, and then the positive test charge will then naturally move in the direction of the electric field. Work is then not required. The potential energy will decrease. Okay, let me check first. Sorry. Okay, and then the difference is this one is the positive test charge, and then for this one pula the point B yang ada positive test charge, so that's why it will naturally move in the direction of the electric field lah. Okay, and then for diagram C, the positive test charge will naturally move in the direction of the electric field. Work is then not required. The potential energy will decrease. And then for this one pula, moving the positive test charge from B to A will require work and increase the potential energy of the charge. So basically, if you are moving against the direction of the electric field here, it will require work. If not, then it will not require work lah. Then if it's require work, the potential energy of the charge will increase. Okay, gitu je lah dia punya concept from these diagrams here. Okay, and then the potential difference between any 2 points on an equipotential surface is 0, hence no work is required to move a charge along an equipotential surface. Okay, hope you can understand based on this one. I've explained it just now, I think. Okay, right. For change in potential energy between 2 points in electric field, so the definition of electric potential difference is equal to this one, and we know that work is also equal to the change in potential energy. Okay, so we then get the change in potential energy equation to be this one here. Okay, so potential energy of a system of point charge, remember for your syllabus, up to a maximum of 3 charge in a system only. Okay, so let's consider this 3-point charge shown here. So basically, how you calculate the potential energy of the system is based on this equation here. Okay, Okay, so yeah, that is basically your subtopic 1.3.